right, let's get going on today. So, yesterday we learned about the box method. The box method is a way for us to do what? Thank you. Box method is a way for us to do what? Oh my gosh, I need participation or we're going to do calisthenics. What did we do yesterday? Why? Thank you, Andrew. It's a method for multiplying polynomials. What is a polynomial? Joey? Okay, it's like a monomial, but it has more than a monomial, right? An easy way to describe a polynomial is it's a multi-numbered math sentence. It's a multi-numbered math sentence, right? So it can be a binomial, it can be a trinomial, it can have 4 numbers, it can have 5 numbers. A polynomial is simply a multi-numbered math sentence. And a box method was one of the first of the 3 ways we're going to talk about on how to multiply polynomials. And like I said before, it's an easy way. A lot of kids like it. It's easy, you set it up. It's not the method I use. Y'all will not use the method learn the method I use until you get to Friday. Friday's the FOIL method. That's the way I was taught. I was taught one way and one way only, and that was it, so I've used it my entire life. Okay, plus it's a more efficient way to do it. But if you want to continue using the box method, I'm perfectly cool with that because it's one way to kind of stay organized. Avery? Thank you. Okay, so this asks us to use what we learned yesterday and to fill in the missing blanks. So someone tell me how you set this up. How did you set this up in order to use what we used yesterday based off what we now know? Ethan? Okay, so tell me how. Like, would you just write 3x minus blank? Okay. Okay, so what is it? Very good. So you basically start to work your way backwards, and that has to be 3x. So keep going, Ethan. Okay. Okay. 15x, positive 15x. Okay. Very good. Which you get from here. Is that what you got? Hold. Joey's. Who sees an error? Avery, what's the error? When you separated this and this, Ethan, where should you have put the minus sign? We should have already put the minus sign there, right? Okay, that's what you did? Okay. And then that puts negative 12x here. So now let's fill in. So to Avery's point, what does that put here? That puts 4 there, and it puts 3x here, and it puts what here? 3x. Very good. Make certain you can work backwards. Okay? Make certain you can work backwards. Very good. Any questions on this? All right, so today we're going to learn something called the double distributive method. The double distributive method is the second of the 3 ways to learn to multiply polynomials. It is, again, not the way that I use, but I will tell you something about double distributive. It is the way, if you get double distributive and you really understand it, then when we get to factoring, which is at the end of Unit 8, which is usually what takes kids and slaps them around a little bit, it will make sense to you. Double distributive is the way to work backwards. It's the smartest way to work backwards. So let me just kind of talk about what does it mean to distribute something? What? You just went so and then like this. What does it mean? What does it mean to distribute something? Mathematically, what does that mean? Riley? Yeah, take a number and spread it out to other numbers using multiplication. Distributing a number mathematically means to take a number and to distribute it out to other numbers using multiplication. So double distribution does that very, very thing. Now, what do we have in the parentheses of the first one? What is that called? It's a binomial. Very good. Two-number system. Could you also call it a polynomial? Yes, because it has more than one. And we have a binomial in the second set, right? Here's the way it works. You take one of your binomials, and honestly, it doesn't matter which one, and you separate it into two numbers. The two numbers in my first one are x and positive 5. The two numbers in my first one are x and positive 5. I am now going to distribute my x to this entire thing and distribute my 5 to this entire thing, and this is the way that it looks. I take my x, and I'm going to multiply it times 2x minus 1. And then I'm going to take my positive 5, and I'm going to distribute it to 2x minus 1. And I have now split my distribution. Now, a mental check. This binomial and this binomial must match. If they don't, you've screwed up. If they don't, you've screwed up. Now we have distribution, right? So now I'm just going to distribute my numbers. What's x times 2x? Very good. 2x squared. What is x times negative 1? Negative 1x. Now, a lot of kids will just say negative x. I would strongly encourage you, if there's an x by itself, that you put a 1 in front of it. Because I don't know about you, but when I'm adding, if I don't see the 1, sometimes I screw that up. So I would go ahead and put the minus 1. Now, is there anything left to distribute in the first set? No, so I'll go to the next set. What's positive 5 times 2x? Do what? Okay, positive 10x. I just said negative, freaked me out. And what is 5 times negative 1? Negative 5. Now, do y'all remember in the box method, remember when you have the diagonals and they ended up being like terms, so when you added them, they just got together? If you did this properly, you end up with like terms in the middle. So when you do your final simplification, you end up with 2x squared. What is negative 1x plus 10x? Woo! Plus 9x. Someone said negative, I heard. Minus 5. And that, ladies and gentlemen, is your simplified final answer. And if you had done the box method, you would have done the exact same thing. Now, here's an interesting thing. I'm going to show you one more, and then I'm going to have you practice it. What I need you to understand is it doesn't matter which one you split. Watch on this one. I'm going to split this binomial. So I end up with 4x and minus 3. You notice I split it. And what goes in between? 3x minus 4 and 3x minus 4. Writing it like that might help you make sure that you do it properly. Now I have double distribution, right? I have distribution twice. So we do this first, which gives us 12x squared. What's 4x times negative 4? Negative 16x, done there, minus 9x, plus 12. If we did it properly, we have these middle-like terms. So we end up with 12x squared. What's negative 16x minus 9x? Negative 25x plus 12. And there we go. Make sure you're writing this down. You do 3. Remember, it doesn't matter which one you split. Make sure you end up with 4 terms after you split it and distribute it. Combine your like terms and simplify it down. All right, don't look up until you have a final answer. Did we talk about the most often made screw up with multiplication? 3 times 2. Here's what will happen. Over the next couple of weeks, there'll come a time where you're multiplying like 3x times 2x, and your mind will tell you it's 5x squared. Right? Is anybody else? It will happen. I'm not kidding. At some point when you're doing like classwork or homework, it's going to happen, and you're going to be like, holy crap, it just actually happened. It will happen. For some reason, the 3x times 2x or 3a times 2h becomes an issue. Shh, do not make me hit you. Okay? So make sure you're careful with that. So you end up with 6a squared. 3a times positive 5 is plus 15a. We go to the next one. Negative 20a minus 50. We have our like terms in the middle, so we end up with 6a squared minus 5a minus 50. Good to go? Any questions on that? Outstanding. So let's talk about one that gets a little bit more complicated. Now, what do you notice about this? This is a what times a what? It's a trinomial times a binomial. Now, if you're multiplying 3 numbers times 2 numbers, how many numbers will you end up with before you simplify? It is, but that's not what I asked. How many numbers will you end up with before you simplify? 6. 3 numbers times 2 numbers. Before you simplify, you'll end up with 6 different individual terms. Now, I will tell you there are actually 2 ways to solve this. I'm going to show you both and show you how it doesn't matter. Let's start with this one. Let's just go ahead and split the trinomial first. So what we end up with is x squared plus x minus 3, right? We split that trinomial, and in between, we place this guy. So 7x minus 1, 7x minus 1, and 7x minus 1. Now, there's a little bit going on, so we want to kind of tap the brakes a little bit, make sure we're going a little bit slowly, and we pay attention to our integer rules. So let's start with this. What's x squared times 7x? 7x cubed. X squared times negative 1 is minus 1x squared. You notice I'll go ahead and put that 1 there. Then I end up with positive 7x squared, negative 1x, negative 21x, positive 3. And again, it's just me distributing every single number. Now I've got 1, 2, 3, 4, 5, 6 numbers, so I'm in good shape, and now I just simplify. The way I simplify is I start with the first term, and I look for any other like terms. Are there any other x to the third, guys? No. So we bring it down. 7x to the third. I'm done with him. Then I have an x squared guy and another x squared guy. There are no other x squared guys on the board, so I end up with plus 6x squared. Done with them. I end up with minus 1x, minus 21x. What is it? Minus 22x, good, and plus 3. And that is the product of that. Now, here's what I wanted to show you before you move forward. If, instead of doing it the way I did it, I had split the second one, I could have done that. I could have written this as 7x minus 1, and in between, it would have been x squared plus x minus 3, and x squared plus x minus 3. I could have done that and done the same distribution, and I would have ended up with the same thing if I was careful to make sure I combined like terms. Now, the difference is when you do it this way that I just talked about, the like terms don't get grouped together. So they're kind of spread throughout the equation, so you just have to be the expression, so you have to be a little bit more careful. Any questions? All right, knock this one out. If you get it right, you win a prize, and you may do your classwork. That is the prize. That is not a bad prize. That is a wonderful prize. It's a gift. In fact, just to really make your day, I'm going to throw in homework on top of the classwork. I'm a giver. You're welcome. It's the gift that keeps on giving, Clark. Okie dokie. I get to 27 to b cubed. I get the 6 to b squared. I get the minus 9 to b squared. And the minus 2b. 2b or? Okay. Plus 45b plus 10 is the 10. So then we end up with a b cubed guy, the 27 b cubed. We have it to b squared minus 3b squared plus 43b plus 10, and that is your answer. Now, what does this quadratic look like? It's not a quadratic. It was a trick question, Shelton. It is a polynomial, but it is not a quadratic because it has the cubed. The cube changes things. Okay? Changes into a cubic. You know what it basically does? Okay, so you know how a parabola goes up on both sides because you're squaring it? The negative side, what happens when you cube a negative number? It goes back to negative, so it does this weird thing. Yeah. Okay? It is not a quadratic. You're fired. I'm calling your mother and taking back the compliment. All right, classwork, homework, ready, set, go. Go.